Hi guys, welcome back to the channel. This video is going to be the first in our new series aimed at helping the starters or the newbies into the hobby. We're going to go through in the series of videos what it takes to assemble the components required. We're going to put them together, we're going to get them working, and we're going to create a small sequence in X-Lights to get you up and running and cover all of the basics along the way. This week we'll just take a look at the components needed to get you started, the minimum that you're going to need just to get yourself up and running and experimenting to see whether you like it or not before you push further. Now it is a bit of a rabbit hole and once you're over the edge it can be difficult to stop, but we'll show you what's needed to just push you towards that start. Before we go any further, I'd just like to say thank you to everybody that's subscribed to the channel. We hit 4,000 subscribers this week and that's great news, thank you. Let's see if we can take it further and hit that magic 10k in the not too distant future. If you haven't subscribed yet, why not? Just click the link below and off you go. And why not give it a thumbs up while you're at it? If you like what you see and you want to help the channel, you can give us a super thanks below or buy us a coffee. It all really helps the channel and it helps us to buy the bits and pieces that we need to help demonstrate equipment to you each and every week. So thank you. Right, on with the fun bit. Now, what does it take to take your house from this to this?
Going on here right now. Holy smokes, that screen is so trippy.
Now the first thing we're going to look at is the lighting, the lights themselves. Now these are called pixels or nodes and they comprise of a multicolour LED with a controller chip and sometimes some power circuitry in there as well. And it's all contained inside this little bullet-shaped pixel. So these are sometimes known as bullets as well from that, because they're sort of bullet-shaped with the LED at the top. Now these come in different types, not only voltages, so they come with 5 volts, 12 volts or 24 volts. They come in standard bullet shapes, or they also come in what we call squares, which are a bit sort of rectangular and just a different PCB layout dependent on your requirements for your prop. I mean, some props you're quite happy with the bullet style sticking out the back, others you want the flat ones. Now I don't have any here, but there's also some gumdrop type ones which are a bit like a bullet but they're shorter. There's also what we call strip, so LED strip, and it just comes on a self-adhesive roll, a bit like this, and you stick it onto whatever it is that you want to run, and there it is. The one gotcha with strip is that it is a very thin copper membrane and it breaks over time. Great, so it's great if it's going to be fixed on something permanently that doesn't move at all, maybe under your kitchen counter or something like that, if you're looking for some ambient lighting there. But don't think of it as being useful for a mega tree where it's going to be flexing and moving all the time, because the copper will start to crack after a year or so and you're going to put yourself into a world of pain. So strip, good for fixed permanent locations where it's not going to move at all. Otherwise, you want nodes or pixels that are wire-based, like these ones here. Now, another new entry to the hobby in the last couple of years is these things called seed pixels. And they are very, very much smaller than our traditional bullets. They are also not quite as bright, but they are a lot smaller and a lot lighter. So there might be opportunities where you want to put these things in instead. The other gotcha with these, of course, is if one of these pixels fails, they're going to be a bit of a bugger to solder, to splice a new bit in there, because there's hardly any room to work, particularly on these ones that are sort of, I don't know, about 1.5 centimeters, 2 centimeters apart, something like that. Very, very small. Whereas with the bullets, you have got quite a bit of wire to play with between the pixels if you need to take one out and work on it. That's the basic starter for pixels. Now we're going to need two things to make these pixels do something. The most important one, of course, is a controller. Now they start from the very small, diminutive little things like this, just a little 2-port pixel controller there, tiny little thing. They get bigger. This is a 3 or 4-port Pi-Hat from Hanson Electronics, and it's designed to sit on top of a little Raspberry Pi microcomputer. So there we are, on a single board computer. It just sits on top like that, and is designed to drive a good number of pixels, up to 800 per port at 40 frames per second. Moving on, we have a very good starter controller here. This is the Baldric from I Like That. Relatively new to the hobby. They only came out midway through 2024, but they're inexpensive. There's no firmware or anything on here that you can break easily. Worst case, if something goes wrong, you turn it off and on again, and then off it goes. So that's an 8-port controller. Each of these 8 ports can do up to 750 pixels at 40 frames per second. As you get bigger, you want more strings of pixels, and so you might want to look at either multiple little controllers or move on to something bigger. This is one of the daddies in the hobby. This is the Falcon F16 version 4 controller, and this has 16 outputs here. We've got 2 power inputs, Ethernet, a little display to tell you what's happening, and you've got a couple of expansion ports where you can plug in boards to each add another 16. So you can take this up to 48 ports with 2 expansions. These have been around a few years now in different guises. There's been a few different releases, and they're very well known and very well respected. An alternative might be something like this Wally's differential controller here. Now this has no standard pixel outputs like we see on our Baldric board here. Instead, it's designed for running pixels further away. So these are called differential outputs. And you plug in a piece of Cat5 cable into each of these, and they run out to a separate little receiver board that has a power supply with it, and you can run 4 or 8 ports or more out at various remote locations. Finally, one of the other big daddies in the hobby is the Culp controllers. This is the K32B controller, and this is designed to run 32 pixel ports plus another 16 differential outputs, and it's designed to run on a BeagleBone Black microcontroller. So these pins here would sit on a BeagleBone Black controller and make you one big controller. So again, this is 32. The F16 was 16, or you've got the Baldric 8, and so on. So your pixels would typically have a 3-wire connection. I've taken the plug off the end of this one and put a data connection onto it, and that is designed then to plug directly into the controller like so. So I can just take this. These are what's called Phoenix connectors, and they come in either 3 or 4 pin generally, and they go on the end of the cable, and there you are, and that's plugged directly into your controller. Now, the final piece of hardware really that we need in this layout is a thing called a power supply, and that's going to give us the power to drive all of these pixels. Now, power supplies come in different shapes and sizes. You'll often find things like this one on Amazon or AliExpress or similar. This is generic, unbranded 5-volt power supply, and it says it's capable of 40 amps at 5 volts. This one is a 12 volts power supply from a brand called Meanwell. Now this one is more expensive than the cheap Amazon special, but for a reason. This one is rated at 26.7 amps at 12 volts or 320 watts. It's an RSP 32012. These are common across Europe and Australia, I believe, but not in the US, where they tend to use a slightly different model called the LRS 350. It comes in the same shape and size box, but the electronics are slightly different to cope with EU regulations over here, and that makes these RSP 320s slightly more efficient than the US ones. Now, the big advantage with the Meanwell here is that it is very, very forgiving when you're starting. It has overcurrent protection, so it will shut down if something is wrong and something is causing a dead short. It will just shut down and protect things. If something goes wrong and there's an over voltage, again, it's going to shut down. If it gets too hot, something's wrong there, it will shut down. So it will look after you. The cheap ones will not. They are likely to just keep going. If there's an over voltage, they'll keep chucking power out. If there's a dead short or something, they'll keep chucking power out until something goes pop. They are cheap and cheerful for a reason. So my recommendation, and all I will use on my own personal shows and on my commercial shows, are Meanwells. So there you go. So decent power supply rather than a cheap and cheerful one. You will see people online saying, I've run cheap and cheerful ones for 5 years, I've never had a problem. Good luck to them. I have had customers come back to me with these and say, oh, all my panels have blown up, or all my pixel controller has blown up. And we discover it's the power supply that's let go and it's taken everything down the chain with it. So not worth the £10, $10, whatever difference. Peace of mind. Meanwell's the way to go. So what else do we need? Well, to start with, you're going to need a PC or Mac that we can run X-Lite's software on. X-Lights is the tool that we're going to use to design the show. We're going to use to configure our controllers. And ultimately, we're going to run the show on it. Now we can use PC with X Scheduler to run the show automatically when the time comes. But it does mean it's tying up your, which could be expensive, main computer for the entire show season. The alternative is to use a thing called a Raspberry Pi or another single board computer like this, and we can run some software on here called FPP or Falcon Player, and that will take all of your sequences. When you finish making them, you put the schedule on it, and then this will play the show. It will send data out of its Ethernet control, its Ethernet output here, to the Ethernet on your controller here via your local network, and that will make everything work for you without tying up your PC. But we'll go through all of them over the next few weeks, so you've got an idea of everything that's going on and how you configure it all and make it all play together nicely. The final thing you're going to think about is, I've got all these pixels, but how do I make them into nice shapes? How do I do these pretty patterns that people are demonstrating on all of their shows? For most people, the answer is things like this. This is a snowflake made out of 10mm coroplast, known as Coro. It's a plastic with a sort of fluted type plastic, 10mm thick, that has been professionally cut on a CNC to give us these holes, which we can push our bullet pixels into. So they just sit, we push them right through. I'm going to give it a squeeze trick. There we go. So they just clip in like so. And then we can follow our wiring pattern, fill it up with these pixels, and we have what we call a prop. So that would be our first prop ready to go. And then we can work out where we're going to put it on our property. Now, as well as that, you'll see people working on horizontal lines or vertical lines, and they're cutting holes in things like plastic piping that they've got from Home Depot or B&Q, and all manner of different options are available. But these are the things you're going to need to start: your pixels, your controller, power supply. Now you're also going to need some cables. So you're going to need a mains power cable to connect your 110 or 240 volts into the input on one of these. And you're going to need a suitable weight of cable to come from the outputs here to the power inputs on your controllers. Once you've got those, a bit of network cable to join your controller to your home network, ideally back to your home router maybe via a switch, and off you go. Now at this point, lots of people will be saying, can I go wireless? Can I use my Wi-Fi? And it really isn't recommended. The reason being is that you might say, oh, my TV's on Wi-Fi and that can play HD quality Netflix or whatever, or Amazon Prime or something. And that's fine, but it's going in one direction. It can buffer it, and it doesn't matter if there's a small glitch, it can pause and then play catch up. With a light show, there is no hit and miss on the data. It's got to get there first time correctly every time. So we would recommend in the hobby wired Ethernet or wired networking wherever possible. So we'll be talking about small network switches as we go along and how we join everything up. And I'll be doing little diagrams to help you as we go. So there we are. I'll put some links down in the comments below for the sort of things that you need. And once you've got your pixels and a small controller and a power supply, we'll hook it all up in our next lesson, which will be in a couple of weeks' time. I'm going to do these every 2 weeks. So once you've got them, hopefully in a couple of weeks' time, we will start to join them all up, and I'll start talking through it as we go. And we'll get our first LEDs illuminated, and then we're well on the way to our first holiday light show. Whether it be Hanukkah, Diwali, Halloween, Christmas, whatever show it is you're working towards, we'll have our first LEDs lit, and off we go down the slippery slope. So I hope you found that useful. Take care, look after yourself, and I'll see you soon. Bye for now.